Okay, so we're going to talk about population and samples. This is the second page of your interactive notebook. Okay, the main difference between a population and sample has to do with the observations as they are assigned to the data set. Okay, so the population is all the elements of a data set. Population being the large group. If I wanted to know something about Port Huron High, that would be the population, where the sample is a subset of the population. Okay, the definition of we have here, it consists of one or more observations from the population. It's a subset. It's very important to understand that more than one sample can be taken from a population. Okay, now other differences that have to do with samples have to do with what the measure is. So if something's calculated from the population, like the mean or the standard deviation, that's called a parameter. If something's calculated from the sample, it's called a statistic. Okay, so both the parameter and a statistic could be a mean or a standard deviation. To differentiate between the two, the parameter is from the population, the statistic is from the sample. How I tell the difference, or how I remember it, I should say, population, parameter both start with P. Sample and statistics both start with S. Now, what's going to happen is very important that you're able to identify a population and a sample. And you need to be very specific. And one thing you need to realize is when you're describing something like a population or a sample, you don't want to just give the number. So we're going to do an example together. So example 1, part A, says a survey of 1,353 American households found that 18% of the households own a computer. So first of all, the population is going to be the whole group that you want to learn about. So the population in this case is going to be American households. Okay, that's the whole group that we're trying to learn about. Now the sample is the piece of the population we use to obtain that. Okay, so my sample in this case is 1,353 American households surveyed. So it's okay for me to write that down. So those are as the sample. The number's okay, but giving the number alone wouldn't be enough. Now, this question wasn't asked, but 18%, okay? I have to ask myself, was that calculated from the population or was it calculated from the sample? Since 18% was calculated from the sample, it is a statistic, okay? I'd like you to try part B on your own, and this is something we will go over in class. Now, another example having to do with this is having you identify population, samples, population parameters, and sample statistic. So what we want to do is read this example and go through and see which of those things are being given to us. Maybe all 4 of these things are there, but they might not all be there. So make sure if you have a question like this, you answer the question being asked. So for this one, it said, for the studies described, identify the population, sample, population parameters, and sample statistic. So our example, in a USA Today internet poll, readers responded voluntarily to the question, do you consume at least 1 caffeinated beverage every day? So the question is, the population. Who is the whole group they're trying to learn about? Okay, well, they didn't actually say who their target or audience was. Some might say it's USA Today readers, but the poll was on the internet and you don't know who have accessed that. So at this point, we're not going to answer the whole population because we'd be speculating. However, we can answer the sample. The sample in this case would be anybody who responded to the poll. So for this, we're just going to say the volunteers who answered the poll. Okay, they didn't actually give us the results of the poll, so I have no sample statistics, and they really didn't do much with the population parameter. So all of these other ones are non-applicable. Now we're going to go on today and talk about qualitative versus quantitative variables. Some of this was in your summer homework. Qualitative is pretty much the same thing as numerical. Quantitative is the same thing as categorical. Okay, these are the two groups you can classify with. Okay, so right here, I'm just going to kind of fill in the blanks. We're not going to spend a lot of time on these, but I do want to make sure that you have a good understanding. So something that is qualitative, and I'm laughing because I spelled this wrong, and I do not want to remake the video. So we're going to just fix this one. Qualitative or categorical variables take on values that are names or labels. Okay, so hair color, eye color, anything that's a quality is going to be a categorical or a qualitative variable. Whereas the difference would be when you come into quantitative variables. Okay, so I'm going to spell it right this time. Okay, quantitative and numerical variables are the same thing. It's pretty much anything that represents a measurable quantity. Now, where some confusion comes into play is there are a few things that are numbers that are not necessarily qualitative variables. So like right here, I'm talking about zip code. A zip code is a number, but what a zip code does is represent a category. And so that would not be a quantitative or numerical variable. However, the difference is, what I think of is, I'm not going to average a zip code. Okay, it doesn't make sense to say the average zip code is 48060.5. So that's one thing that helps me in this situation. Now, if something is qualitative, you can't really break it down anymore. But if something is quantitative, it can be broken down into two groups. Those two groups are discrete and continuous. Okay, discrete is pretty much countable. Okay, even though it might be a lot. It's anything that naturally rounds or rounding is indicated. Examples of this might be people. Okay, books. Because those things are whole numbers or they naturally round. Now, if something's not discrete, it's continuous. And I like here how it says a variable that can take any value between its minimum and maximum value. It's pretty much uncountable. So a lot of things are where the confusion lies. Something like miles or distance. Okay, if I ask you how far you live from your house, that's going to be a continuous variable because one person might say I live 5 miles from school. Somebody else might say 5.5. Somebody else might say 5.125. Okay, so that's going to be that's going to be continuous unless I say miles to the nearest tenth. That's why for discrete I say rounding is indicated. Okay, so there's a couple examples we're going to do here. We just want to identify whether the variable is continuous or discrete. Okay, so A says, suppose the fire department mandates that all firefighters must weigh between 150 and 250 pounds. Okay, so we know the numbers in between. It doesn't say to the nearest pound. They gave me a minimum and a maximum. So this one is going to be continuous. Okay. And then right here, suppose we flip a coin and a coin counts the number of heads. Well, when you flip a coin, you can have 1 head, 2 heads, 3 heads, 4 heads. So this would be an example of discrete. Okay, so right here, I'd like you to write any questions you may have so far. Okay, this will be a place where on your note sheet you can indicate that, and then when you come in, you can ask those questions. The last thing we're going to talk about today is univariate versus bivariate. You probably have dealt with these terms before. If not, you kind of know some things that would help you. Like a unicycle has 1 wheel. So univariate data pretty much deals with 1 variable in the data set. Okay? A bicycle has 2 wheels. So bivariate data, you're going to have 2 pieces of data set. It's kind of like when you do correlation, you're comparing things. Like if I said the number of hours studied and went with your GPA, that would be a bivariate data set. Okay, so the last thing I'd like you to have done, just right here, you can see there's a list of several variables. I'd like you kind of to go in, take a look at each of these, identify them as either numerical or categorical, and then any of them that are numerical, say they're either discrete or continuous. We will talk about this in class.